fact, I just bumped into somebody in the hallway earlier, and we ended up talking about it, and he had a very different perspective on the whole talk than I did. That just happens because we had a collective experience and we're walking around.
Okay, that is an empty slide. So the thing is, I love exceptions. I'm sorry if that offends anyone. The reason I love exceptions is because they solve a very inherent problem with programming, which is you have one location where you know where the problem, that there is a problem, and another location where you know what to do about that problem. But that very same disconnect between where the problem happens and where the handling happens causes us a problem when you try to diagnose via logs or debug, whatever. One solution is to use backtrace, and many languages actually do that. They put a backtrace object on the exception object. The problem is, it's not a very good solution for several reasons. First of all, let's face it, C++ doesn't have backtrace inside the standard exception objects, so it means you need to use non-standard objects and handle memory location, etc. And it doesn't work well with release builds that tend to fudge the stack frame. And there's a problem with loops. Let me explain. If you have an initialization loop, and that initialization loop calls the same function several times, the backtrace won't tell you which iteration the problem happened in. Now, there is one solution of sorts. It goes, I'll call it catch and release. You use a non-standard exception object that allows mutable something, either a string or whatever. And then the area where you know something interesting is going to happen if an exception happens, you do catch, you add the context, and there you have all the variables you want onto the exception object, and then you rethrow. That's the release part. Does anyone here think this is a good solution? Yeah. So you need a specific exception class, and it's intrusive. Boy, is it intrusive. I have a better solution. This is the exception context class. All you have to do, the code remains exactly as it is. All you have to do is add this one line at the beginning that instantiates a variable. That's it. You put all the potential logging information into that variable's constructor, and that's the last time you have to deal with it. If this was a happy path exit, nothing happens. If, however, that object gets destructed because of an exception, there's a global, or thread local in this case, place that collects all of those classes along the way. And then we can log them later. I'll just point out that this is a part of a project I started and abandoned of creating a new programming language. And when that project got abandoned, I started asking what parts of this can be salvaged to C++. So long live abandoned projects, whatever. Anyway, at the catch site, where you place it normally, you don't have to do anything different. You just access that global object and ask it to dump the trace. And you get a list of all the places along the stack frame that had a logging location. And the thing is, obviously, it's less intrusive. You don't have to change the exception class you're using. You can use the standard exception classes, and this still works because it doesn't rely on which specific exception you're throwing. And in the happy path, there's no to very little overhead. The worst case is if you're using a string, then you might need to copy the string into the object. But all the heavy lifting happens only on the set path, on the exception. Where do you get it? This is part of a project I'm just starting called Fibers, which is a micro-threading library. If you're interested in the dead programming language, it's there, and my YouTube channel. That's it. I'm on time. 5 seconds to go.